Okay, so I'm going to try my best to answer your questions related to understanding the difference between a true odds ratio and a true rate ratio, or a true anything, a true number for a population, and what it is for a sample. So I think a lot of your misunderstanding relates to the fact that you're not thinking through the actual study design and how studies are actually performed. So watch what I'm going to do here. You're not going to have to do this, but it's going to help you see what we do in statistics a little more clearly. So we'll say that we're interested in generating, I don't know, GPAs for all the students at a particular college. We'll say that we'll generate random numbers between 0 and 4. We're just going to randomly generate numbers between 0 and 4, and we'll say that these are the GPAs rounded to the nearest whole number for a university. We can say it's EKU. Now these numbers won't hold up for EKU, but we'll say it's for EKU. We'll say that EKU's got, I don't know, 11,000 students. So I'm just randomly generating GPAs for 11,000 students, potential students. Well, maybe we'll just do 10,000 so I don't have to copy down so many rows. So we'll do it for 10,000 students. Or we'll say that it's 10,108 students. So I just randomly generated numbers between 0 and 4 for 10,000 and I don't know, 10,108 students. We'll say that this is our entire universe, or our entire study population. And this is their average GPAs. Or not their, this is their GPA to the nearest whole number. So hopefully you're still following me. So I've got this huge number with this GPA all the way for that. All right, so for the whole population, I'm going to hit average. I want the average for everything, the whole population. So I can scroll up all the way, or I can just type it in here to D1. So what's the average from D1 to D10108? So there it is. It gives it to me. It's 2.0304. Okay, so this is maybe our population that we're interested in. Now, say you're doing some sort of study where you want to know the GPA for all the students at the university, but you don't have access to the computer. You don't have access to their data. You want to do a survey, but the numbers aren't available. It may not be practical for you to do a survey on all 10,109 people. They may not all participate. So instead of getting the true average, you might get the estimate. So maybe you have enough money to do a survey on a smaller group of this. So we'll just pick. I started here at 4,700. So maybe we randomly survey 100 people. Okay, I'm going to copy this 100 people, and we're going to move this 100 people right here. So this is GPA 100 for 100 people. So we have the GPAs for 100 people. Now I'm going to maybe randomly select, I'll just scroll down, the GPAs for whatever this is. Maybe, let's see, about 20 people. Maybe we only study 20 people. So I'll put GPA about 20. I don't know the exact number. Every time I hit a button, it wants to change on me. So I don't know why it. Okay. So I'm going to copy these to this program here called Stata, and then I'll copy them back. So here's what I'm going to do. I'm going to copy these numbers, this variable name. So that's the GPA data copied, and then it probably changed our average at the bottom. So now the average is 1.98. So okay, so this is what we've got right now. So 1.9865 is the GPA for the entire universe. Everybody will say there's 10,108 people. Now, I put it over here in Stata because it locks it so it can't change and keep randomizing. So now, you know, when I paste, you might see the other numbers changed. Those numbers changed. Well, we still got the original numbers right here. These things are locked, you know, so they're not going to change. So the average for these numbers, since I copied them into Stata, is still going to be 1.98654. All right, so they're locked, so they're not going to change. So say we want to do a study, but we're not going to be able to survey all 10,108 people. So we randomly pick, maybe, I'm going to just scroll down. We randomly survey 100 people and ask them what their GPA is. So we survey these 100 people. Let's see, it didn't copy. So we survey 100 people, copy. I'm going to paste. So this is the GPA survey of 100 people. Then we survey, I'm going to scroll way down somewhere else, and we're going to pick, let's see, just 20, all I picked was about 20 rows. So I'm going to paste them here. It's the GPA for 20. So here's our data. So remember, okay, so now look. The real population, if you were actually able to survey every single person and census everybody, the average would be 1.98654. That's the average. Okay? Now, that's not sometimes practical. Maybe at a university where we collect data, but if you were trying to get the average body weight of an EKU student, or the average, or what percentage of EKU students are smokers, yes or no. If you were trying to do that, you may not be able to ask all 10,109 people. We can get all their grades and have that all recorded, but if you were to do a survey, okay, you wouldn't be getting the true average, you'd be getting an estimate of the true average. So when we do the survey, say we survey 100 people, okay? Here's the average that we get for these 100 people. I'm going to scroll up. All right, so we get an average of 2.17. That 2.17 is a lot different, well, it seems a lot different than 1.986. If we just surveyed 20 people equals average, how's this compare to our overall average? 2.15. So these two numbers right here are our estimates, but are they wrong? That's a question that deserves to be asked. So there's a confidence interval. There's an actual confidence interval, and there's a way in the program in Excel to calculate that confidence interval. But instead of calculating that confidence interval in Excel, we might I can put it into Stata, and then I can do it, in here. So it's copying the data. So I have this variable is the same variable as GPA. It couldn't rename it the same thing. But we have GPA 100 and GPA 20. These are our variables, okay? Or the variable names, the outcome. It's the GPA. I can type in summary statistics for GPA, and it will give me the average for the whole group. The minimum was a 0, the max was a 4, the average was 1.98. I can do the same thing, summary statistics for the GPA of 20. It was 2.15. Summary statistics for GPA 100. When we surveyed 100 people, 2.17. Now the question is, what is the confidence interval around our average estimate? So there's a way to do a thing called a t-test that we'll do later on in the class that I know will immediately provide the 95% confidence interval. So if I want to do a t-test of the GPA for everybody versus the 20, there's a way to do that. You have to do statistics, summaries, t-test, mean comparison test, 2 samples using groups, 2 samples using variables. Okay, so the big GPA versus GPA 100, it runs. So it gives us our averages here, okay? You see the mean? This is the average for the entire population. This here, GPA 100, is the average for 101 observations. About 101 people we surveyed and asked them maybe, what's your GPA? Now, this had everybody. This was our universe. But was the average of 2.17 wrong? Well, actually, we were 95% sure that the true average actually fell between 1.88 and 2.46. So this confidence interval is saying, how sure are you? Well, we are 95% sure that the true average, so our estimate was 2.17. The estimate fell in the middle of our confidence interval. So the average GPA in our survey of 100 people was between 1.88 and 2.45. We were 95% sure that if we did this over and over again, it would always be there. What about for when we do our t-test, versus instead of 100, we do the one that was just 20? Well, our confidence interval should get larger because we have less samples. So now we're 95% sure it's between 1.5 and 2.79. So the true average was 1.986. We estimated 2.15, but we were 95% sure it fell between 1.50 and 2.8. So I'm going to make another video as it relates to odds ratios here in a minute.